Hello, everyone. Um, Welcome back to day 39 of me coding every day. Today is a Sunday at 1:06 p.m., February 23rd, 2025. In recent news, I completed all these graph problems. Kind of went through them. I'll probably revisit them. So yesterday, I did some more dynamic programming problems. So I did longest palindromic substring and palindromic substring. So today, I'm thinking coin change. So this is one of those famous problems that I think everybody kind of knows. Um, I like a couple years ago when I was first starting to get into data structure and algorithms, like I kind of was exposed to it, but I don't think I've ever actually solved it before, and I don't really know how to solve it off the top of my head. I think it's a pretty standard dynamic programming problem. I don't expect to get it right away. I'm expecting it'll probably be pretty difficult for me to get it in n times t. So yeah, I'm just gonna go for it here and see what we can do. And if you see me check that, I'm just making sure I'm not muted there. Okay. So coin change. You're given an integer array coins representing coins of different denominations, $1, $5, etc., and an integer amount representing a target amount of money. Return the fewest number of coins that you need to make up the exact target amount. If it's impossible to make up the amount, return -1. Okay, so this kind of reminds me of combination sum. It's very similar to combination sum. So combination sum is basically this problem where you have numbers and you have an amount, like a target, and you have to sum any combination of these to get the amount. But in combination sum, you return, I believe, the number of combinations. Here, we're returning the fewest number of coins. Okay, so let me start with the decision tree. So we'll look at this first example, 1, 5, 10. So we start with 0 coins, and from there we can either do 1, 5, or 10. Let me draw it out a little bit more. So we can either do 1, 5, or 10. And that will place us at 1, 5, 10. I just want to draw it right. All right, so then we'll get 1 here, 5 here, and 10 here like this. Okay. So, and then from each one of these points, we can do it again, right? So we have 1, 5, 10, and that would give us, say 1, 5, 10, and that would give us 2, 6, 11. This would give us, so we can do 1, 5, 10, give us 6, 10, and 15. And this over here, 1, 5, 10 would give us 11, 15, 20. Okay, let me just silence my cell phone. All right. So if you notice, and then this is not all. So we would basically just keep doing this for everything until we are equal to or greater than 12. So for instance, this is greater than 12, so we're going to cut out this pathway. This is greater than 12, so we're going to cut out this pathway. Same with this, right? But you'll notice there's some repeated. So before we worry about that, in this solution, anytime you encounter a 12, we would look at the number of coins it took us to get there. And so for instance, if here we took like 2 ones, right? So if we went 11, 12, we would take the number of coins to get there. And then if it's less than the lowest we found so far, then we make it the least. Okay, so that's the problem. But you'll notice, right? So here we have a 10, and here we have a 10. So both of these 10s it's sort of like the Fibonacci problem, if you've ever thought of it, if you've ever done it. So here, instead of calculating 10 all the way over here and, you know, all the possibilities of 10 over here, we can store the result of 10 somewhere. So that way when we encounter 10, we can just grab that result. In this case, it would be the number of coins. So here we would say like, okay, it's only taken us 1 coin to get to 10. So if we encounter 10 here and it's taken us 2 coins, we can just not, we don't have to calculate any of this because we know that everything in this answer has to be lower than anything we could ever calculate here. So that's the idea. In terms of coding it, I think what I'll do is start with just the brute force implementation and see if I can do that. And then we can add the dynamic programming element on top. Okay, so let's get started. So I'll make a function called DFS. So what we'll do is basically just, you know, depth first search, sort of explore the tree like this. Okay. And then what we want to do within, so this will take an amount, well, we could say like current change. Okay, and then each time we want to say for denom, for which stands for denomination in coins. I'll just say for coin. Okay, so for coin in coins, we want to call it again with current plus coin. Okay, so we want to call it coin many times. So like in this case, they call length of coins equal to n. So we want to call this n times, right? So here we'll call it 1, 2, 3 times for each branch. Our base case is if current is greater than, so if it's greater than 12, we can just return. If it equals 12, then we want to update max. So for now, I'll just make a global variable called, I guess I could say result, right? Which will be, we'll set it to infinity. Okay, so if current equals 12, we're going to check if the coin amount, so then here we're going to say num coins. So every time we're going to pass num coins plus 1. So we're going to keep track of the value itself, but also the number of coins that we've taken to get here. So here would be like 6, 2, 10, 2, 15, 2, etc. Okay. So if the value, the coin value, equals 12. So instead of current, maybe I could say value. Okay, so if the coin value equals 12, then we want to update our max. So we'll say result, and then let me just say non-local result. Okay, result equals equals the minimum of itself and num coins. Okay, so let me try here printing num coins and see if this, I'll just return it, I guess. Actually result instead. See if this gives any errors. Okay, so I never call the function, that would make sense. So we want to call it with a value of 0 and a number of coins equal to 0. That should be our start case. Okay. Oh, and if it's not possible, so what did I output? 6? And I, okay. I also hard-coded 12 in my solution here, so that's interesting. But hey, that's fine. All right. Okay, case 2 is infinity. So we should implement this as -1, but the problem is that nothing will ever beat -1. So okay, let's try this. So if it's infinity, we'll return -1. Okay. TLE. So this shouldn't TLE. This should so I must have an infinite loop somewhere where it's not reaching the base case. Or does it actually just TLE? No way. Does it TLE even from this? Okay, so my dilemma right now is it TLEing because it's the brute force solution, or is it TLEing because I have an error in the code that's causing an infinite loop? So if value is greater than amount, well, I guess here I don't return, right? I should return. Could that be why? Well, if we think about this, all right, let's think about the time complexity. Because I know here it would have to go 11. This does seem like it would take a long time. Okay, so let me just assume that this code is correct because it passes all of these test cases. Let's wait. Hold on. It passes this one. But it fails. I don't output anything. So when I click run, this test case works. Okay, so I'm gonna assume that when I TLE, it doesn't tell me the one that it TLEs on, I suppose, because when I press run, this case is accepted, and then when I submit, I get TLE, and it shows me this case, but I'm assuming that it's actually a different case causing that error, because this one we know passes. Okay, so let's assume that this is correct for the brute force implementation. So now let's create a dictionary. I'll call it like cache. I think that's what convention is for dynamic programming, or I could just call it DP, or I think also you call it memo. I'll just call it DP. Okay. So we want to store. So the first thing, if we encounter, so I guess right here we could do the DP element. So if if value not in DP, so if it's not in there, then we should add it. So DP of value equals current number of coins. Also, if num coins is less than DP of value, so if we found a new minimum, then we should say that DP of value equals num coins. So these are the same code here. So let's say if it's not in there, or if num coins is less than DP of value, then we should update it. Okay, if it's greater than, so if num coins is greater than DP of value, then this means we can cancel out this branch. And I think it has to actually be down here, because this has to be bounded, and we only know if it's bounded after we've checked this. Okay. So if value equals amounts, and then maybe we don't need this, right? So this will just build, let me make sure I'm not muted. Okay. So this will just build the dictionary. And then perhaps what we can do is just return dp of amount. So we can say if amounts not in dp, or I guess this makes more sense, return dp of amounts. So if it is a possible combination, then we can return the minimum that we found so far. Otherwise, we should return -1, like this. So let's see what errors. We probably don't need that anymore. Okay, so that seems to work. I also just would like to print dp here and see if if it makes sense. So 0 takes 0 coins, 1 takes 1 coin, 2 takes 1 coin, 3 takes 2 coins, 4 takes 2 coins, 5 takes 1 coin, 6 takes 2 coins, 7 takes 2 coins, 8 takes 3 coins, 9 takes 3 coins, 5 2 2, 10 takes 2 coins. Okay, yeah, it looks good. So if I submit it, what happens? Time limit exceeded. Time limit exceeded. Okay, so a way that I kind of like to so I'm going to submit get TLE, use test case. Isn't this the same as test case 1 though? Okay, so I'm just getting TLE. So let me think, let's look at the edge cases here. So if the amount is 0, what happens if I say, well, this example does work. Okay, amount can be, let's say amount equals 10,000. Okay. So if amount equals 10,000, then I get maximum recursion depth exceeded. So I thought this would I thought the whole point of this was that it would prevent that. Maybe I'm supposed to return here. Let's think. So if value is not in DP, we update the table, and is that it? Okay, so if value is greater than amount, then of course we want to return. Also, if so I'm just thinking of how to order this. If it's not in DP or it's less than, then we should set it. Okay, so this prevents an infinite loop, but now I'm getting the incorrect answer. So we have 0, 0. And I guess we're never calling the function again is the problem. Let me see if it works for just 1,000, if it works for 1,000. What about 20? So it works for 20. What about 100? 100, it does not work for 1,000? Maybe here is where I can check it. So I can say, if I don't know why this would make a difference. So the reason I'm doing this is because amounts can be equal to 1,000, or sorry, 10,000. So I'm just kind of like manually binary searching to see like where. So 150 works. I think 200 I didn't try yet. Is it because I'm printing? Sometimes printing could take a while, but it shouldn't, because it shouldn't be that big. Okay, so 150-ish kind of works. So does it get to 150? So 150 equals 30. So maybe if, because when do I guess I'd never really check that if, maybe what I should say instead also is if it's greater than or equal to the value, then we return. Because if it's greater than the value, then we don't care about this one. Maybe I could do this instead. I mean, shouldn't change anything, but so this will get me the minimum number of coins. And if it doesn't exist, no, I don't think that's important. All right, so let's check the order here. So every time we visit a number, we want to see if this number, if we've already visited this number. That's. Well, we also want to check the value. Let's just forget about the value for now. So if we say if we've already visited this number, so if we've already visited this number, then either yeah, we don't want to stop actually if it's the, so we have to explore the full tree, but we can just trim stuff. Or is there another element to it? Well, I was going to say maybe if we've used 2 coins and got a bigger value, but that's not necessarily true because, okay. So if we visited it already and its value is less than the number of coins, so if we visited it before and we've done it with less coins, then we want to return. Okay. So I guess we can say if it's visited and we've done it in less coins, then we can return. Otherwise, we should say dp of value if we've done it in less than or equal to coin, like the coins that we're at. Otherwise, we should say it equals num coins. That's the dp element. So I guess we don't need this. If the value is greater than the amount, we can return. So if we're calculating something for 160, but we only care about 150, we can return. Okay. I feel like this just does the same thing though. So this will make 2 and then 4 and then it'll exit out. I must be missing some part of the... Okay, so now it's just wrong. So I'm getting -1. So if the value is not in DP, I never add it. So should I just say it here? Because we want to do it regardless of whether it's in it or not. Okay. And then this we could obviously add an and. Okay. So I guess that worked. I really... Okay. Let me look at the difference. So I had the right idea, but my code wasn't correct. So let me look at the difference of this submission and other submissions and see what I was doing differently. Okay, so this was interesting. Okay. So here I say a value is greater than amount, return. If it's not in dynamic program, so if we haven't seen it before, or could it be or? Did I mean to say and? Well, I basically just reversed the logic on this. If numCoins is greater than... Maybe it was this part. Okay, so this part's the same. Let's look at this part. I think like with De Morgan's theorem, like it's the exact same thing. So value not in dynamic programming. Oh, but I don't... Oh, here I just return. Okay, so if I were to write this... So if value not in DP or DP of value greater than numCoins. So I had this, but I was setting it. Oh, is this why? I think I had the wrong sign here. Well, no, I said this is fine. So if we haven't seen it yet, I guess I never check. I was going to say we never check if we've seen it and it's greater. If numCoins is greater than DP of value, so this doesn't work. Let me see if I change it like this. So, okay, so there's two cases. If it's not in dynamic programming, then, so if it's not in our cache, we add it to the cache. Or it is in the cache, but we found a smaller one. Okay. Okay, so I'm going to try changing this. so I understand why. If it's not in DP or num coins, yeah, that makes sense to me. If num coins is it the order? But here we can get an error because it will say that we don't know if it's in DP or not. Unexpected indent. Copy. So this will give me an error. What if I separate it like this? Does this work? No. So this makes this is totally fine, I'm pretty sure. Basically we're saying if it's not there, then just add it as the minimum one we found so far. Is it because this needs to be down here? Because we weren't adding the new minimum? But these only one of these can run. It can't be both. And I hit the same function call, right? Value plus coin, num coins plus 1. Wow. I mean, obviously I have the right solution, but I don't really understand why this one is wrong. This makes sense. Maybe I'm not doing this, but I'm doing it here. Okay, so what about this? So in this case, I'm thinking if we get here, then we know it has to be num coins has to be less than or equal to do I just have a if num coins, if the current number of coins we're using is more than something that we've done before, then we should return. Yeah, same thing here. I don't think the equal sign matters. Because this right here. And we know if we're at this point in the code that it must be in DP. Is it this part? Am I not supposed to do that? Okay, so now we're returning out DP value. Oh, Oh. Is it because we're adding it to the dictionary and then checking it with the one that we just added? Okay. I think that was the problem. So if I go to, I still like my first accepted solution better. I just wanted to understand why that wasn't working. So this one. Oh, okay. Wait. So I think it's because I'm updating the value. Okay, let me try copying this solution. So this one gets DLE. Now if I put L here, does that fix it? No, okay. Okay, so let's look at least this solution here. So what I was doing with this one is, if it's not in there, then I'm adding it. And then, of course, this is true. Oh, but I shouldn't return out? Wait. Whoa, okay, maybe I don't understand it. So this solves the problem? So here, both of them are possibly running, and here only one of them can run. So if by adding L here, if this happens, this will get skipped, and this will also happen. Okay, so this solution is correct. So that's fine. If it's not in it, add it. Then I add it again. And then do it. Okay, let's say it is in it. If we've already found something, then we return. And we don't do anything. So why is it that when I have an if here, oh, it's because this never gets to call. Okay, I see. So this, the first time we encounter something, right, it's going to say, okay, we haven't encountered it before. We're going to add it. But then this part says, if it's less than or equal to, then we just get out. So we don't actually finish calling the recursion. Okay, what about this solution here? Even though I already solved it, I feel like kind of doing this and really understanding why it does or does not work is useful to me at least. So, okay. So here this one fails. All right, so let me understand the fail point. So why is this code different from the solution I have in my head or the solution that I wrote? Okay, so the solution I have in my head is we see if, so when we first get there, we check if value is greater than target, then we return. So we have that. Also, if we've visited it before, if we visited with less, then we also return. So that's what this solution is. So this solution, if it's a value we don't care about, we get out. Obviously, I can add an and here. So if we visited it before with less, so we visited it with less than we currently have, then we get out. If those two things are both false, then this code is reachable. So we'll update it. So if we have not visited it, or we have visited it, but this condition is not true. So if either one of these is false, then this code is reachable. So we add it, either add it or update it, the new number of coins to be the min in the DP dictionary, and then we continue to recurse. Okay, so that's fine. All right, so there's basically 3 scenarios. It's not in the dictionary, it is, but we found something better, and it is, and we have not found something better. Okay, so let's run through, let's trace it. If it's not in the dictionary, what happens? So if it's not in the dictionary, what we want to do is A, add it to the dictionary and then continue recursing. Okay, so if it's not in the dictionary, this condition is true, which means this whole condition evaluates to true because of OR, and this executes. So we add it to the dictionary. DP of value equals num coins. Okay, and then here, this will be false. This will be false because num coins at this stage equals DP value. It is not greater than, so this will be false. So this will get skipped, and then it will recurse. So if it's not in the dictionary, we're good. Check. I'll say works. I don't know how to make like a check. I'll just do a smiley face. Okay. If it's in dict but we found something better. In dict but found something better than this. Okay, so if we found a faster way before. So this is not true. Okay, this evaluates to false because it's in the dictionary. This expression, num coins, in our case, num coins is greater than DP of value. So this is false or false, which is false. So this gets skipped. Num coins is greater than DP value. This is true. So here we'll return out and do nothing. So this also works. Because this will evaluate to false and get skipped. And this, well, okay, so this will evaluate to true and get skipped. So in this case, yeah, we don't actually want to recurse anything because this is a dead path. Okay, so that also works. Haven't found faster way before. Let me make sure I'm not muted. Okay, still good. So if we haven't found a faster way before, so this will evaluate to true. This will evaluate to true. So this will be true. This will be false. And then we'll keep recursing. So that is also true. So does it all work? Because if we haven't found a faster way before, it is not. Okay, so this is actually false. So if it's not in DP, maybe this. Okay, wait, I might have messed that up. So if we found a faster way before, so it is in this. So this evaluates to false. This evaluates to false. Okay, false or false, yeah. Okay, so that works. Here it's false or true because num coins should be less than DP of value. So it's false or true, which is true. So we update it. This is false. All right, so honestly, tracing it that carefully, it seems like it should work. So I honestly don't know why it doesn't. If anyone knows why it's not working, let me know. Like I said, I was able to get like a real solution. It must have, so it's getting TLE, so the dead branch is not recursing though, because in this case, and then this works, right? Or was that something else? Was that a different example? That was a different example. Okay. So it should not be recursing though, but it is updating it, but it would be false anyway, right? Oh, the dead branch, I'm calling this a dead branch. So when we should kill our branch. Oh, wait, is this it? So if the value is not in dynamic programming, so this is false or true. Oh, okay. This is the reason why. So this works. This does not work. Sad face. And the reason is, so this part is true. It's not. Wait. Hold on. Value not in dynamic programming. It is. So this part is false. Wait. I thought that was evaluating to true, but it's actually not. Okay, I guess I don't know why. If value not in dynamic programming, this expression is false because it is in dynamic programming. Wait. So it is there. So this evaluates to false. Or does it evaluate to true? It evaluates. Okay, so if we have it like this would be true. So this would be false. It's not in there. That's false. It is. And then this is also false. So it should be getting skipped. So yeah, I'm not really sure. I'm not really sure, but either way, for this problem, what I was able to do, I'll just leave it at that and just accept that I don't understand why this doesn't work. It's just like I could bang my head into it forever. But either way, so this solution, I guess just sometimes rewording it in a way that makes more sense to you is a takeaway from this. So I kind of just scratched the logic, reset, and then did it this way. And this this makes more sense to me. And just for the exercise, let me do the same thing with this one. So if I don't know which code I was just at. Okay, so if haven't seen, have seen better, haven't seen better. Okay, so if we haven't seen it at all, this is false. It's false and something, so it just is false. Then we add it, and then we recurse, so that looks good. So add to dict and recurse. Have seen better. So this is like the dead branch. This is the dead branch. So if we've seen better, this is false. Do I have like less than amount? No, I have greater than. Okay. So this will be true. And this will be true. Because we've seen something better. So we just return and do nothing. And do not recurse. Which I believe was the same thing that was happening in the other one. If we have not seen better, then we want to update it and continue recursing. So if we have not seen better, so this is the best one that we currently seen. So this evaluates to false, this is true, and this is false, so that gets skipped. DP of value gets updated and then we recurse. Yeah, so update and recurse. All right, so that's everything. So I'll definitely look at this in my free time and see what happened, or you know, how they did it. So this is CoinChange. This is my version of CoinChange. I think it makes perfect sense. Basically, just do the brute force solution, except you add the DP. So I don't know if this is called bottom or top down or bottom up, but basically I'm building the dictionary first, and then just returning the final dictionary amount. So I don't know if that's bottom up or top down. But yeah, so that's day 39 for me. Thanks for watching. And yeah, I'm still grappling with dynamic programming and stuff. So sorry if that was, sorry if that was easy for some of you. But anyway, thank you for watching. And I'll be back tomorrow for day 40, I believe. So that's exciting. All right. Thank you everyone for watching.